Hello, my name is Hadi Farhangi on Basics of Statistics, Hypothesis Testing, One Population Proportion. Topics of this video: first, an introduction, and then hypothesis testing of one population proportion. First topic, introduction. A standard normal has a bell shape with the mean of 0 and variance of 1, which we are going to use in this chapter. Calculating standard normal probabilities using Google Sheets is through this formula: probability of z less than equal to x is norm that this, inside parentheses, x, 0, 1, and 1, separated by comma. Hypothesis testing investigate the claims about variables. Such claims can be as follows: the mean of variables is decreased, increased, or changed. The mean of variable is greater, smaller, different than another variable. The variance of a variable is increased, decreased, changed, etc. Definition: hypothesis testing is a process to test a claim, and it concludes with either rejecting a claim or accepting it. Note that claim is shown with HA or alternative hypothesis, and its logical opposite is shown with H0 or null hypothesis. In every hypothesis testing, one should state H0 and HA first, which dictates the setting and shows how to proceed with the testing. The steps for hypothesis testing using p-value are: step 1, state the setting of the hypothesis testing. Claim gives HA and its logical opposite gives H0. Step 2, calculate p-value. It is the probability of being outside the confidence intervals. It depends on the distribution, type of test, etc. Step 3, if p-value is less than alpha, then one accepts the claim or reject the null hypothesis. Otherwise, reject the claim, or you may say fail to reject the null hypothesis. These are the 3 steps you should follow if you are doing hypothesis testing using p-values. Next topic, hypothesis testing of one population proportion. This section investigates the claim about the proportion or percentages of a single population. For example, one may have a claim about the percentage of defective products in a production line, or about the percentage of the home runs in a basketball game. All these kinds of claims are about proportions. Such claims can be: 1, proportion is not a certain value or two-tail test. 2, proportion is bigger than a certain value, right-tail test. 3, proportion is smaller than a certain value or left-tail test. One should find the setting of the hypothesis and calculate p-value to conclude the hypothesis test of proportions for one population. The value of proportion for a population is given as p. A sample of size n will be selected, and the proportion for the sample should be calculated and named p hat. If n times p is greater than 5 and n times 1 minus p is greater than or equal to 5, one can use a standard normal to calculate p-value. The critical value for a standard normal then be ZC, or the critical value of a standard normal, p hat minus p divided by the square root of p times 1 minus p divided by n. More on hypothesis testing of one population proportion If n times p greater than equal to 5 or n times 1 minus p is also greater than equal to 5, one can use a standard normal to calculate p-value for this test. The critical value for a standard normal for this test would be zc is equal to p hat minus p divided by the square root of p times 1 minus p divided by n. P is what we claim about, and P hat is the approximation from the sample claim. Proportion is different than a certain value. It's a two-tailed test. The setting will be H0, P is equal to that value, and HA, P is not equal to that certain value. And P value will be calculated at 2 times probability of Z greater than the absolute value of ZC that we see above in that formula, P hat minus P divided by a square root of P times 1 minus P divided by M. Claim proportion is greater than a certain value. It's a right tail test. The setting P0, H0 is P less than equal to value, HAP greater than certain value, and P value is calculated at probability of Z greater than ZC, as ZC is calculated as before. As you can see, Z greater than ZC and P greater than that certain value, the sign is the same. Claim proportion is smaller than a certain value. Test type left tail test. The setting H0P greater than equal to a certain value and HAP less than a certain value to represent the claim. That P value is probability of Z less than that ZC. And as you can see, the signs are in HA and p-value is the same. If p-value in all these tests less than alpha, then one accept the claims or reject the null hypothesis. More on hypothesis testing on one population proportion, and here is an example. The mortgage department of a large bank is interested in the nature of the loans of first-time borrowers. This information will be used to tailor their marketing strategy. They believe that 50% of first-time borrowers take out smaller loans than other borrowers. They perform a hypothesis test to determine if the percentage is the same or different from 50%. The sample of 100 new first-time borrowers, and they found 53 of these loan borrowers are smaller than other. They loan smaller than other borrowers. For this test, they choose 5% level of significance. Answer. First, based on the question, n is 100, p is 0.5, and alpha is 0.05. And p hat is 53 divided by 100, which is 0.53. Second, since np is 50, greater than 5, and n times 1 minus p is also 50 greater than 5, the test can be done. Step 1. The setting is H0P is equal to 0.5, HAP is not equal to 0.5 because they want to test that. Step 2. Calculating p-value is first we have to know Z hat, and it will be 2 times probability of Z greater than absolute value of ZC. So the p-value is 2 times probability of Z greater than absolute value of ZC, and ZC is p hat minus p divided by the square root of p, 1 minus p divided by n. We have all these values, we plug in, and we get 2 times probability of Z greater than 0.6, which is 2 times probability of Z less than minus 0.6. If you do the calculation, it is 0.5486, which is not less than alpha, which is 0.5. So we reject the claim. Percentage remains at 50%. Examples for the case of right tail or left tail test different from this in calculation of p-values. The rest would be the same. Particularly, step 3 will be the same. If p-value is less than alpha, we accept the claim, otherwise we reject. Like this example that it has been rejected because p-value is not less than alpha.